Hello everybody, welcome. This is paper 1 from May 2022, and this is time zone 1. So I think this is actually quite a challenging paper. Question 8. A factory produces bags of sugar with a labeled weight of 500 grams. The weights of the bags are normally distributed with a mean of 500 grams and a standard deviation of 3 grams. So already we kind of know we're in the realm of normal distribution. Write down the percentage of the bags that weigh more than 500 grams. So one mark question here. So part A, sometimes it's a good idea to draw a sketch to kind of see what is going on here. So we have a situation, number of bags of sugar, they're normally distributed. We have a mean of 500 and we have a standard deviation of 3 grams. Write down the percentage of the bags that weigh more than 500 grams. And in this case, it's going to be all the values to the right of the mean. And since this is the line that divides it, without even using norm CDF, we can, of course, we know that this is equal to 50%. One of the things that is kind of tricky on this is they're asking for the percentage of bags. So looking at the mark scheme, if you were to write 0.5 or 1/2, it would actually be marked as incorrect. So just be careful. If writing down the percentage of bags, we would want to write out a value of 50%. Okay, let's go on to part B. I'm just going to move this because I think I might need the space. Part B. A bag that weighs less than 495 grams is rejected by the factory for being underweight. Find the probability that a randomly chosen bag is rejected for being underweight. So here we go once again. This is, in this case, a 2-mark question, so we'll be expected to show some process. I'm going to actually redraw this just to make it a little nicer, or thereabouts. Mean of 500, and we want to find the probability that a bag weighs less than 495. So let's draw a line. It's going to be to the left here, and it would be 495. And we want to find the probability that a bag weighs less than 495. All right. So we're looking for this area right here. In this case, we have the cutoff point and we want to find the area. So this is going to be norm CDF. That is to say, we're looking for this percentage to the left of this cutoff point. So let's go ahead into the calculator. Let's go menu, probability, distributions, and we're in norm CDF. Lower bound we can keep as this massively negative number. Usually you just want to make sure that you sweep out all the area to the left. So usually like 5 standard deviations is enough. So you could put 100 and it should be fine, but this massive negative number should be okay as well. Upper bound 495. This is our mean, and our standard deviation was 3. Alright, so it looks like roughly 0.04779, or roughly 4.8% of the bags are underweight. So let's go and write that out. For a 2-mark question, this would actually be your process. You can also write norm CDF, and then we can write -999, 495, lower bound, and then this would be our mean, and this would be our standard deviation. 0.04779, and we want to find out the probability. We can represent this as a decimal or fraction or percent. So to 3 sig fig, 0.4, and then this 9 would go to 8. So we have 478 if you want. 4.78%, all the same. Okay, part C. A bag that weighs more than k grams is rejected by the factory for being overweight. The factory rejects 2% of bags for being overweight. Find the value of k. Okay, so this is a 3-mark question, a little more challenging here. Same idea. I think it's always a good idea to draw a graph. just because it helps scaffold things, so far as I see it at least. So a bag that weighs more than k grams is rejected for being overweight. The factory rejects 2% of the bags for being overweight. So in this case, if it's more than a certain cutoff point, so now we're looking for a cutoff point and not a percentage. We have the percentage. If it weighs more than k grams, it's rejected. And 2% are rejected. So in this case, we're looking for a point right here, or thereabouts. And we want to say, okay, well, if we know that 2% are rejected here, 2% of the bags are rejected here, what is this cutoff point k? And what makes this a challenging kind of 3-mark question is the idea that, remember, our calculator sweeps out from left to right. So if this is 2%, then we know that everything to the right here, or sorry, everything to the left, is going to be 98%. So when asking the calculator what areas should we sweep through, it's not 2%. If we chose 2%, it would actually just be this area right here, which would give you a very small number, or one that definitely wouldn't be overweight, not greater than the mean. So we're asking the calculator to sweep through 98%. So let's go ahead and go back to the calculator screen to work this out. Menu, probability. In this case, we want to go inverse normal. So the area that we're asking the calculator to sweep through is 0.98. The mean, remember this mu is the mean, and the mean was 500, and our standard deviation was 3. Alright, so there it is. A bag must be equal to 506.16 grams. If you were to work this out and you were to put 0.02, you'd get a value less than the mean, and then hopefully that should be a signal that this can't be overweight if it's less than the average. Alright, let's go back to the document and write this out. So this is what we did. We did inverse normal, and we fed in an area of 0.98 with a mean of 500 and a standard deviation of 3. And we got a result of 506.16, or just 506. So what do we know? We know that this k value is equal to 506. Okay. Alright everybody, I hope that was helpful, and as always, best of luck. Take care.